Welcome back. This unit and this video are all about 2D arrays. We're going to get introduced to them. We'll do a little bit of coding where we basically just make one and kind of loop through it. And we'll save the tic-tac-toe code for a different video because it may need to be maybe we need two parts on that. I don't know. So there's no denying that arrays are extremely useful when it comes to storing data in a sequential list. I know we got introduced to Arraylist, and y'all may think that arrays are just worthless, but keep in mind that an Arraylist just manages an array behind the scenes. Each Arraylist object just has an array as an instance variable, and all the Arraylist does is manage that. So realities are the Arraylist is an array, so you're welcome. However, in our 3D world, a 1D data collection is very limited. In order to represent a chessboard, an image of the Grand Canyon, a Microsoft Excel spreadsheet, etc., another dimension is needed. That's where 2D arrays come in. In Java, a 2D array is an array of arrays. Visually, it looks something like this, right? Here in this kind of bronze-looking color, that's an array. Each element is an array. Right, so this is one way to look at it. I find that it helps to visually think about it like this, and you start to see the grid or table layout by visualizing like this. We still see the outer array, and each individual element is an array. Now, if you just look at the white ones and kind of maybe cross your eyes and stare at it for a little bit, you kind of start to see the grid come together, and that is ultimately our 2D array. In practice, a 2D array can be used as if it were just a table, a matrix, a grid, right? This thing here is kind of this is what a 2D array is. It helps to visually maybe think about it like this, where you have an outer array with each element being an inner array. In practice, it functions like this, just any grid. So the question then becomes is, how do we make this thing? Here we see a construction statement. That's going to construct a 2D array capable of storing 12 ints in total. So this is an integer array. All right, let me show you what I mean. If I had a board in front of me, I would write some stuff and cover it up, right? If we were just making an int array, it looks something like this, right? This is an array capable of storing ints. Okay, what the 2D array is an array capable of storing integer arrays. That's how I love to think about it. Now, of course, as we saw in the slides, we're going to need a second length over here, which we'll talk about what those things mean. But this is our 2D array. Again, it is an array that is capable of storing integer arrays. Each individual element in this array is an array. So in our construction statement, we can store 12 total ints. Again, visually, it looks something like this. So based on this, this graphic and our numbers here, you should be able to infer some things, right? What is this number? It's going to be our rows, which means this is going to be our columns. So the left-hand side of the construction statement declares an int array variable, as I should say like a 2D int array variable, called nums, right? The data type of nums is a int 2D array. This syntax is consistent with what we've used in the past. Nums is an array capable of storing int arrays. Each int array can then store ints. The right-hand side of the construction statement constructs a new 2D int array. The outer array will have a length of 4, while the inner array will have a length of 3. I don't like to think about it in those terms, right? It seems kind of weird because the way I'm kind of explaining it is that you would think that this is the outer array, meaning the second number is our outer array. But just bear with me here, right? This is rows, this is columns. A specific element in nums can be accessed by referencing the corresponding outer array and inner array indices, right? So here I have the 4x3, right? 4 rows, 3 columns. That's our 4x3 2D int array. The particular spot right here is nums at 0, 0. We're talking row 0, column 0. whereas this one right here is row 2, column 1. And again, these elements start at 0, kind of like we would expect. All 2D arrays on the AP Computer Science exam will be traversed in row major order. That is, each column in an individual row will be accessed before advancing to the next row. Let me kind of visually show you what this looks like, and then I think it'll make a little bit more sense. What I'm about to show you is row major order. It's how the College Board tends to write their questions, right? So say we're going to start here. I finished off the entire row before moving to the next, right? We're visiting each column in the row before moving to the next. That is what row major order is. In order to accomplish this, you have to use nested loops. For the most part, everything we did in CSP, everything we've done in CSA, you've been able to get by without having to nest loops. There's no doing that here. You need to nest loops in order to traverse a 2D array. So what I'm about to show you is how do we traverse in row major order using nested loops. Let's consider this 2D int array. Here I have nested loops, right? I have a 4 nested inside of a 4. Our outer loop is going to control our rows, basically. Right? Notice that I've named the integer r, indicating a row. Here, in our inner loop, we've named the integer c, indicating our columns. So this will loop through all of the elements, and in this particular case, just print them off. One thing I'd like you to notice, actually, I think our slides are going to break this apart, so let's step through it. The outer loop is used to select the row. That's the way I like to think about it, right? We've clearly labeled it r, but its function also reflects that. It's going to select our row. So initially, we're going to be on row 0. Our inner loop is going to be to select the column. Keep in mind what row major order is. We're going to go through every column before moving on to the next row. And that is what we're doing here with our nested loops. Note that the outer loop traverses the length of the outer array. Right, we're starting at index 0. We're going through nums.length. That is the length of the outer array. If we look back at our example, we gave this thing 4 rows. And if I told you to kind of think about this thing visually as something like this, the way that we were able to achieve 4 rows is that the outer array has a length of 4. So that the outer loop traverses the length of the outer array, while the inner loop traverses the length of each individual inner array. Keep in mind that this 2D array is really an array of arrays. So I'm on the first row. That very first element is an array. So I'm going to loop through that. Here we're using R in order to basically say, what is the length of the current row? We'll talk about that more in just a second. Let's code. Let's make a 2D int array. I'm going to create a new project by going to File, New Project. We'll go Next, Next. I need to jump to my CSA folder. And I'm going to name this one like Intro 2D Array, something like that. 2D Arrays. It doesn't really matter. This is basically just a folder. I'm going to expand my project folder, right click on the SRC, do a new Java class. I'm going to call it the same thing, 2D arrays. Now, I'm not beginning this with a number 2, right? In theory, I want to do 2D arrays. Can't do that, right? This is going to be a user-defined symbol, the name of the class. We cannot begin with a digit. We could do this. That looks awkward to me. So I'm calling it 2D arrays. Again, it doesn't really matter. We're going to go ahead and plug in our main method. And let's create a 2D array. Right? I'm going to create an integer array. You can call it whatever you want. Nums works. It is a new int array. And the numbers I don't necessarily care too much about. The main thing I want to emphasize is just giving them different values, right? I don't particularly want to make a square. I want to clearly show that this is our rows, this is our columns. Okay? Quick reminder that if we just try to print off nums as it is, you're not going to get what you want. Right? When I do this, is basically just going to be my pointer. It's going to be the location in RAM, all that jazz. Some of you may be thinking, aha, we went through this with the arrays class, right? We wrote, when we got introduced to 1D arrays, we ended up writing our own toString method to see the contents of a 1D array. And then we later learned that there's an arrays class where something like that is already created. So I'm going to import that arrays class, and let's print this bad boy off using the toString out of the arrays class. And that doesn't quite work. Okay. It turns out there is a way to, out of the arrays class, see the contents using a toString. It's just called something different. Arrays deep toString. Right? It's got to work a little bit extra because this thing has more dimensions to it. So I'm going to do this. I'm okay doing this because I know it's not going to be exactly what you want, right? This is a 2D array, but the way that we're looking at it as if it's just a 1D array, notice that we have the outer bracket here in here. That's because it is one array where each individual element is an array. But viewing your 2D array like this is confusing, right? I want to be able to display it with 3 rows, 2 columns. So I'm going to leave that there. But what we're going to do is loop through it. I'm going to say for I. I'm going to use this opportunity to rename my counter variable to R. And then I'm going to tab over. We're going to say as long as R is less than nums.length. Inside here, I'm going to do another for I. I'm going to use this opportunity to rename this C. And we'll say as long as C is less than nums at R.length. Okay, so the outer loop is going to select the row. I'm on the first row starting out. I'm on row 0 starting out. I'm going to loop through the columns on that row. All right, this is row major order. We're actually going to end up doing all of the columns before advancing to the next row. While I'm at this row, I'm going to ask how long is this current row? That is the number of columns, right? The length of the row is the number of columns. While I'm here, I'm going to print off the current element. The current element is going to be nums at RC. And we'll take a look at what that looks like. I think you're going to agree with me that we're going to want like a space or something. I get this. Okay, so I want you to kind of maybe pause, think for a moment. I ultimately want it to be displayed as rows, columns, meaning we're going to have 3 rows with 2 zeros on each row. Right now, I got 6 rows with only 1 zero. So the way we're going to handle this is that we're just going to print the current element without creating a new line. Now, when I'm done with the row, that's when I want to do a new line, right? I want to go 0, 0, new line, 0, 0, new line, 0, 0, new line. The moment that we're done with the row is after we've processed every column. So outside of this for loop, but inside of my row, we can just do a simple print line there. And I think you'll see what I'm talking about. Right? This is a 3 by 2. I would consider putting in a space here to clean it up. But there we have it. 3 rows, 2 columns. Right. We're filled with zeros initially because this is still an int 2D array, so we use the default value for int, which is 0. Let's learn a little bit more, then we'll play with other values. Right. We could actually use an initializer list. in order to construct and fill a 2D array. This would be another spot where I would kind of invite you to pause and see if you could figure out the initializer list. But I'm going to continue on. Here's an example. And I've color-coded these braces to indicate that this is the outer array. This particular example is going to have 4 rows. Now, I have formatted it in a manner that kind of replicates the end result. But it's going to be a 4x3. We got 4 rows, 3 columns. But only because I made it that way. Coming back here, I'm going to comment out nums. Right? I'm just going to reuse these loops. All these loops are doing is traversing the 2D array. I'm going to recreate nums, but this time I'm going to use a initializer list. Right? This is kind of the gist of the syntax. Let's make a 3x2 again. The first element is going to be an array. And this time around, I'll give it values. Right? The first element in nums, the first element in the outer array is an array. The elements in there are 5 and 2. I'm going to maybe do another row, which this needs to be separated with a comma, and I need to use the actual brace. Let's do something like that number and that. And then lastly, let's do one more row. I'm going to align those. And then fat finger some more stuff. And there we have it. I kind of recommend setting it up like this so that it reflects the number of rows, the number of columns. In theory, it could just all be like this, right? Here is the braces that indicate the outer array. This array has 3 elements in it, and thus 3 rows. Inside of that, we have 2 elements, 2 elements, 2 elements. And because I'm consistent there, we have our consistent 3x2. I'm going to loop through that, printing off the elements. And we get something like this. You could probably understand that like some formatting would go a long way. But the gist is still there. 3 rows, effectively 2 columns. Okay. If I wanted to change an individual element, we can come in here and say nums is equal to, nums at a particular spot is equal to, so let's say I want to change the very first element. Well, that's at index 0, 0, row 0, column 0. I'm going to make that something. Right, so I use the initializer list to create our 2D array. I immediately change the first element. It was a 5. It should be 80 now. And then we print. Okay, I'm going to maybe change one more element. Let's say I want to change this guy. This guy. I want you to think for a moment what that spot is, and then execute. That's going to be on row 0. It is the element at index 1. Again, those get changed before we print, so you'll never even see the old value, the 2. We already replaced it. So we can create a 2D array this way. We can use an initializer list. In either case, you can use this syntax in order to change an individual element. Okay. While not really used on the AP Computer Science exam, you could traverse a 2D array in column major order. So we saw a visual on row major. We actually looked at the loops on row major. We actually wrote code to go row major. Everything we've talked about is row major, which is like 95% what you should see on the AP Computer Science exam. What does column major actually look like? Keep in mind, row major, we visited every column in the row before moving on to the next row. So column major should be the inverse of that. We should visit every row in the column before moving on to the next column. Visually, it looks like this. My question is going to be, How do you do that? What do you got to change? I want you to think for a moment. You're going to need nested loops. It's going to look something like this. Let's say that we have nums, and it's a 2D 4x3. I'm going to set my outer loop to go through the columns. I'm going to set my inner loop to go through the rows. And that's effectively it, right? I actually just flipped those two things. Notice that we're still accessing via row column. This could be confusing to students at first, but think about like a coordinate plane where the location on that coordinate plane is still x, y. It doesn't matter, if you go rise over run or run over rise, in order to get to that point is still x, y on the coordinate plane. Excuse me. Okay, so here we have our row major order comparison to our column major, right? For the most part, it looks like all we did was flip the order on our nested loops. There is a subtle difference between the two. Notice right here we said nums at r, and here we said nums at 0. Okay, I think students can quickly recognize the reason why. I mean, here, r actually doesn't exist. R doesn't exist until we actually get inside the loop. But in our previous example, we use nums at r.length when we're doing row major, and nums at 0.length when we're going column major. When traversing a 2D array in either row major order or column major order, you can simply refer to the length of the first inner array, that is nums at 0.length, provided the 2D array is rectangular. Okay, what am I saying? Let's flip back to our code here. This is row major order. Right? I'm doing my rows as my outer loop, my columns as my inner loop. What the slides are saying is we can just do this. Right? I can do nums at 0, and I'm going to show you that, and we're going to get the exact same result. Okay, while we have that change in place, I'm going to show you column major. Keep in mind that the output should still look the same. It's just the order in which we're going through it is different. Just kidding. Our output changed because I'm going column major as opposed to row major. Okay. Now, if I tried to do R here, you see we get a syntax error because R doesn't exist. We can use 0. We have to with column major, but you can use 0 with row major as long as the 2D array is rectangular. So here is some vocabulary. Right, here are some examples of rectangular 2D arrays. Simply put, a rectangular 2D array is if each row has the same number of columns. Right, here I see one that's kind of square. Here I see one that's rectangular, but it's got 5 rows, 3 columns. Here we got 3 rows, 4 columns, but all of these are rectangular. Each row has the same number of columns. What this implies is it is possible for a row to have a differing number of columns. Here's our row major showing that we can use the nums at 0. We've seen that. It is possible for a 2D array to have a differing number of columns per row. We call that jagged. Okay. The main way that a jagged 2D array can be achieved, you should keep in mind that none of the 2D arrays on the AP Computer Science A exam will be jagged. You are only going to be tested on rectangular. I'm merely showing you jagged because it adds value to the concept of it being rectangular. Okay, the easiest way to achieve a jagged 2D array is through an initializer list, right? Here I created a 2D array, and it's rectangular only because I told it to be. I gave each row the same number of values, but it's actually super easy to come in here and add another value, right? I'm going to loop through, and we're going to see that. We're going to see that the number of rows is the same. In this case, 3 rows. But the number of columns, this actually is going to end up being a very good example. I added a value here. Why didn't it show up? Well, ultimately, it is because, right, when I'm looping through the columns, I'm asking for the length of row 0 only. Well, that one had 2. So I'm only doing 2 iterations when I'm on any of the rows, including the one here in the middle that actually has 3 values. This is the whole point at why I showed you the original code. The best way to do row major is to ask, what is the length of the current row whenever you're on the current row? By referencing the row here, this is just a more dynamic approach. Okay, so while you can use 0 on rectangular 2D arrays, I would say that it is good practice to reference the length of the row so that you can handle jagged arrays as well in the future if you need to. Okay, for this class, for the AP exam, you should understand that those things are interchangeable, right? We can use R, we can do 0, because the arrays are going to be rectangular, not jagged. With a jagged 2D array, you will need to know the length of each inner array. That is, you'll need to use the outer loop's counter variable when determining the number of columns. Right? The number of columns is the length of the row. Let's recap. In Java, a 2D array is an array of arrays. This is, I guess, a true-false question. It's just a fact. In Java, a 2D array is an array of arrays. I don't really know how other languages tend to handle this because I just never go that deep into other languages. Given a string 2D array, how many rows do we have? I'm basically asking which of these numbers is the rows, and it's the first one here. This should have 2 rows. What expression can be used to access the integer 6? Right? I want to pull that value out of the values 2D array. Right? That's going to be values at 2, 0. Right? We're going to go to row 2, which is 0, 1, 2. And then we're going to access the first one out of that, which is at index 0. Accessing each column in a row before advancing to the next row is considered blank traversal. This could be hyphenated or multiple words. This is going to be row major. All right, with row major, we complete the row before moving to the next row. We visit each column in the row before moving to the next. A 2D array is set to be blank if every row has the same number of columns. It should be rectangular. A 2D array is set to be blank if the rows do not have the same number of columns. What is the opposite of rectangular in this case? It's going to be jagged. And we're going to pause there. We'll do a separate video for tic-tac-toe. I'll see you in the next one.